How does light behave? What is light? What is it? Is it some airy-fairy atmospheric thing that just floats around? How do we shape it? How do we use it? How do we make someone look pretty? So how do we make someone look more dramatic with light? There are so many different ways, but this is the first step of my 5-step process to a well-crafted photograph. So let me go through it. What affects the quality and quantity of light? Well, there are many factors. Of course, it's the size of the light source. That'll affect the quality of light. The intensity, it's the power of light. The distance of the light to the subject, that's going to affect it as well. Your camera angle, because you can have the exact same light, but the minute you change your angle, it's going to appear quite different because you might be exposed to more light or more shadows and so on and so forth. And then, of course, you've got your light angle, which we've just discussed. Now, I am going to get into a little bit of the science behind light, and you may have heard of the dreaded inverse square law. What does that mean and how does it affect what we do? I'm going to quickly touch upon the mathematics of it all, but I'm going to mainly get to the heart of what it's all about and why you arguably should need to know it. So let's go through it here. Now, this is going to confuse the heck out of you, so don't be intimidated by it, but basically what is it? The inverse square law is the intensity of the light, the power of the light, equals 1 over the distance squared. Now, I'm not a mathematician. I did a bit of algebra. I wasn't that good at math, but we've done some homework here for you and put it in sort of simple and layman's terms. So let's say, for example, we've got the distance squared, so 1 over the distance squared, that is the distance. Let's say it's a foot, okay? 1 over the distance squared. That distance squared, okay, is 1, okay? So 1 times 1 is 1. 1 over the distance squared, 2 by 2, is 4, and so on, and so on, and so on, and so on. So why I've grayed that out, so ultimately, if we work out what the distance squared is, okay, now we have 1 over 1, 1 over 4, 1 over 9, as in 1, a quarter, a ninth, a 16th, and so on. When you translate that into the percentage of light, what happens is we've got 100% of light. So let's say the distance from the camera to the subject, let's say that represents 100%. We have to start somewhere. So let's call that 100%. So we've got there 100%. This is the most important factor because you might have been taught this and think, why do I need to know it? This is just a pain in the butt. What do I do? Well, this is the biggest part of this equation. All you simply need to know is once you double the distance from the actual light source to the subject, you actually lose up to 75% of that light. But do you see how it actually diminishes very, very slowly here? So double the distance and you lose basically 3/4 of your power. And that is a big factor. You need to know that. So when you've got either an on-camera flash or an off-camera flash, whether you have a reflector or whatever, you double that distance, you lose 75% of that light to the subject. Okay, so hopefully that is the easiest way you've ever been explained the inverse square law. But what other factors come into play when we talk about it? Well, let's go through it. Not only are you reducing the power of the light, you're actually losing the, you're increasing the size of the light as you go further away, which is almost counterintuitive. You almost might think the opposite. It's funny because the inverse square law, and I was doing a bit more homework because I've only really learnt it and taught it in relationship to light. But as I did some more research here, it actually applies to the gravitational force, electric field, of course, light and sound or radiation. So it's quite fascinating that these laws exist, but they help us to understand everything a little bit better. So we're talking about the light source, and let's say this little line here represents the original distance from the light to the subject. So what happens is, although this is a certain size, this is actually small, let's say small, it is what it is, the size is what it is. Once you go further away, you can sort of see how I've actually used these colours to represent that it's almost desaturating. You know what I mean? Like we've got less power. And of course we do, because here we said the distance from the light to the subject, that represents 100%. When we double the distance, okay, so original distance, we double it 2 times over here. Now we're actually reducing that power, like I said, by 75%, but we're multiplying it by 4. So it's actually spreading out, but it's losing its power as we go further along. So ultimately, to basically sum it up and what we discussed, again, remember, double the distance from the light to the subject, you lose 75% of that light. And of course, as you go further away, the more it spreads, but of course the intensity decreases. Once you understand those things, then it makes it a little bit easier. I'm not really even suggesting that arguably you go into a shoot with these mathematics and freak out. You just need to know those basic fundamentals so that you can understand how the light behaves and know that when you're turning your flash on, like, what's going on? I moved my subject, 1 meter back, and all of a sudden I've got hardly any power left. Well, that's because of the inverse square law. And what I want to do now is I'm actually going to show it to you in more of a practical method by shining a flashlight on a piece of paper, and let's see if we can prove this theory. Light travels in straight lines. So each ray of light has its own path until it deflects or bounces off something which continues, of course, on another straight path, and so on and so forth. So let's look at our drawing here. We've got the light source right here. Light travels in straight lines. It doesn't get squiggly, it doesn't wrap around or anything like that. It'll just go on there, and then it will deflect if it has something to deflect from, and it will keep on bouncing accordingly. That's a fundamental, but we just need to understand that it's pure physics. This is what it's all about. Now, the intensity of light reduces as the subject and light are moved further apart. That's a pretty obvious one. If this is your subject and this is your light source, as they get further apart, the intensity will reduce. Now let's prove it. So let's say this piece of paper represents the subject, and then let's say where the light is right now represents 100% of that light, okay? Of course, we need a starting point. Now, we just established that the inverse square law suggests, or actually factually says that if we double the distance from the light to the subject, we reduce the intensity of light by 75%. So we've just shown you that. Not only that happens, so we're reducing the light by 75%, but we're also making it bigger. If we go to the slide here on the screen, you can see that the number 1, that sort of orange looking box there right in front of that light source, that's the intensity of the light there at 100%. But when we double the distance, now we're multiplying that area that the light is covering by 4. So let's prove that in actuality here with our example. So you can see that if this represents 100% of that light source, if we double the distance, then you see how now we're getting a bigger light source. The problem is we're getting a bigger light source, but we're losing the power or the intensity. To go back to our analogy of water, so right now we've got this small hose and it's quite sharp and it feels quite tough on the skin. When we go a little bit further back, it actually feels larger, so we actually feel more water on our body, so to speak, but it's less pressure. Now, yes, there are a couple things that come into play here. Now, if you look at that diagram back there again, so you've got, if it's with a speed light, for example, you've got the bulb inside the flash head that if you zoom it in or out, the spread of that light becomes different. So you have to understand, although that this is an actual proven principle in physics, you have to understand it's going to be a little bit different depending on the light source, and in this case, in the example that I'm giving you, the flash head. So let me show you this now as well. So you see, actually, let's see this. So let's say, for example, this is the widest that we can do the flash head. All right, so the zoom, the flash head within the actual unit is right at the end, giving us a wide spread. It looks small now because it's close to the actual area. Now I can zoom this, and do you see now how small it is? So when the actual flash head comes closer, then what's on screen right now is maybe not exactly correct based upon that flow. So again, depending on the pressure of the light, the intensity of the light, if you can zoom the flash head, then arguably that particular diagram that you're looking at now will be wider or narrower depending on those things. But again, guys, remember that as you bring the light source away from your subject, it gets bigger, which is fantastic because we can say, you know what, if I need a bigger light source and photographing a big group, I just bring it further away. The problem is I need more pressure, as in more intensity of light to illuminate everything that I want. So it's a bit of a give and take thing. So remember that, practice that, and have some fun. So remember this, the larger the light source relative to your subject, the softer the light. So here we have a good friend of mine, Rainey. She's actually against a white background and it's very, very cloudy. Okay, so we basically have a very, very large light source. Because it's basically so big, it's very soft. Because you can think of it like if it's not the sun isn't the light source anymore. The clouds have diffused the light and now the whole sky, the clouds, everything is the big light source. So the transition from light to shadow is not so great, it's quite soft. It's less descriptive and all those different things. Now, let's look at the difference. The smaller the light source relative to your subject, the harsher the light. So now the clouds have gone away and now we basically have the sun as the light source. Now, people think the sun is big. It is per se, but it's quite small relative to my subject. So arguably it is a small light source. And because it's so small, the harsher the light, as in the more contrasty it is. You can see the shadows are deeper. We've got a very defined shadow against that sort of white background there as well. So it gives us a completely different look. So if you look at the comparison, there's a large light source, there's a small light source. And that could be likened to basically anything. It could be a big window or a small window. It could be a larger flashlight or a smaller flashlight. It could be a big softbox or a small, and so on and so forth. If you look at, this is actually Melissa's 40th birthday shoot. Yes, she looks amazing for 40. Very, very proud of her and her heart and her beauty. This is open shade, it's quite overcast, so we have a big light source. It's very soft, okay? So it's very complementary. You might be using this kind of light source if you want to have maybe some challenging skin and you want to soften the skin. Maybe you have maybe aging parents or grandparents and you find open shade is really, really nice. So therefore, this might be really good. But then when the light source is smaller, let's say there's no cloud now, the sun, so the sun is small relative to clouds, now the light source is smaller, we get it more contrasty, it's more sharper. We've got sharper edges, we've got the transition from highlight to shadow is more abrupt than before, as you can basically see. So what we're trying to do is just give you some fundamentals that you can take in your next shoot, whether it's a wedding or a portrait, whatever it may be, but these are fundamentals that you basically just need to know. So let's talk about this one. The closer the light is to the subject, the darker the background. So this is basically shot in a hotel room. This was a dark background. I think it was a black background. But as you can see, just off the actual perspective of this photograph is a window. Because she's quite close to it, the background becomes darker because I have to expose for her, as in get detail on the brightest highlight in her face, which forces the background to pretty much go pitch black. Now, if I change my angle, so now I've got her from let's say for example, the bedroom window was basically here and she was facing this way in a profile. Now she's over there up against this grey wall. So the further away the light is from the subject, the lighter the background. Because of course the value of exposure between the bride here and the wall are quite similar. So therefore we have that effect. If I wanted that background darker, I simply get her closer to the light, expose for her correctly, as in I want detail in the brightest highlight in her face, then of course that background, although grey, might appear a dark grey or possibly even black depending on how far away we are. And it's amazing too that all we have to do is just change our angle. So she stayed there, I changed my angle to camera left or her right, and then we get this photograph. So there is so much to photography that you can't take anything for granted, and there's no absolutes. That's why in many occasions I'll say, The larger the light source relative to your subject, the darker the background and so on. Well, it depends that, see, we could be using a large light source, but we could be shooting on the fringe of it, which now becomes a small light source. So if you look at these 3 photographs of the same girl in the same room, although this was quite a large light source, it was a large window, I had her on the fringe of it, and really we've got a tickle of light on her face and a little bit of her ear. We turned her shoulders, so only a hint of her shoulders in light, but the rest is in shadow. Well, now it's sort of become a small light source. And of course you may recognize that that's a part of the banner behind me there as well. So we need to practice these things to sort of really understand how we bring out the best in our subjects and what kind of mood we're trying to create and things like that. And of course, we're going to discuss this further as well. So let's talk a little bit further about how light behaves. Remember, the closer the light source is to your subject, the sharper the shadows on your face. So if you want something or your subject to be more dramatic, bring the light a little bit closer, and then you've got that light and that shade that's going to be a little bit more contrasty. The further away your subject is from the light source, the softer the shadows. So for example, if you're photographing parents or grandparents and you want a softer transition, you want a little bit of modeling, as we call it, making a face look more three-dimensional and with shadow, but you don't want it to be so abrupt between light and shadow, bring the light further away and it's a little bit softer. A good example also is if you're photographing, let's say, a plus-size bride who you might want to use shadow to cut in and actually make her look slimmer, but she also maybe have bad skin. So that shadow makes her look slimmer, but it's not so abrupt between light and shadow. But the softness of that light is actually going to make her skin look a little bit softer. So there's a good example of that in action. Remember, smaller, harder contrasty light means the transition of light to shadow is more abrupt, which creates deeper shadows. You might actually recognize my work. I love deep shadows. I actually, I just think they're just so dramatic. Very, very cool. And I'm not always after absolute perfect detail in blacks. No one said that you have to have detail in blacks. Maybe if you go to a competition, you will often hear a judge say, well, I don't see any detail there. Quite simply, there is no perfect exposure. There's no perfect light. It's basically perfect, or the execution of your desired result. Do you want deep shadows? Do you want black in those shadows? If that's what you want and that's what you execute, then you've done it. No problem at all. Remember, larger, softer light means the transition of light to shadow is more gradual. As we sort of previously discussed, you sort of saw those photographs of Rainey, my wife Melissa, where it was a little bit soft, it blended in a little bit. Some people like that soft look, and depending on the body type, the shape, the skin type, these things come into play, and that's really, really important. And ultimately, guys, remember this. We often say that lighting is the most important thing technically in a photograph, or in photography per se, but really it's actually the opposite, in my humble opinion. It's a subtraction of light that creates luxury, depth, mood, dimension, and shape and form, and all these different things. That's what it's all about, is where do you take away the light? Once you take it away, and we'll discuss this in future segments, it becomes very, very beautiful. You start to see a beautiful three-dimensional form and shape. You see texture, all these different things. So we're going to learn how to almost light something completely and then take away light, and that's what's going to create that beautiful mood and make images just pop off the screen, pop off the print, and just look gorgeous as you're looking at a beautiful album. So bear with me, we're going to simplify it even further.